Compound probability, lesson 13.4. Here's our warm-up. Question 1, what is the probability of spinning a vowel or flipping a heads? So our spinner down here is color-coded. I wrote the sample space out alphabetically, and then I also wrote the sample space for flipping a coin. You either get heads or tails. So we want the probability of getting a vowel or flipping a heads. So on our list, there are 2 out of 7 vowels. Or means we're going to add, and then the probability of getting a heads, there's 1 out of 2 ways to get heads. 11/14 would be our answer. This is compound probability because we have 2 separate events. The first event is spinning, and the second event is flipping the coin. So compound means we have 2 or more events occurring. The second question, what is the probability of spinning a vowel and flipping a heads? Well, the only thing that's changing is us getting heads and the fact that we have this word and. So the vowel is still 2 out of 7. Getting heads is still 1/2, just like getting tails. And means we're going to multiply because both of those events have to occur. So fractions, we do numerator times numerator, denominator times denominator, cross cancel if you want, and then we can reduce. In today's lesson, we're going to be talking about compound probability, independent and dependent events, and then mutually exclusive events. We're going to have a couple formulas that are going to help us along the way. Independent events is the occurrence of each event does not affect the other. So some examples would be landing on heads after tossing a coin and rolling a 5 on a cube. Another example, choosing a marble from a jar and getting heads on a coin. Getting a 3 from a deck of cards, replacing it, and then getting an ace on the second card. And the last example, rolling a 4 on a die and then rolling a 1 on a second roll. All of these events are independent because the first experiment does not affect the second. So our probability for finding 2 independent events is the probability of A times the probability of B. So again, compound events is an event that is made up of 2 or more events. An independent event is the occurrence of an event that does not affect how another event occurs. And the opposite of that would be a dependent event. The occurrence of an event does not affect how another event occurs. So here's an example of 2 events that depend on each other. The probability of it storming out and the probability of me going golfing. If it's raining, I'm not going golfing. So that weather report is going to change whether I go golfing or not. So here's an example. My desk drawer has pens and pencils and paper clips in it. If you select a pen and a paper clip from the drawer without looking, what is the probability you'll get a blue pen and a black paper clip? So we have a total of 11 pens, and we have a total of 40 paper clips. So that gives us our sample space. We want the probability of blue and the probability of getting black. So we're going to multiply. So when we dig in the drawer, we're going to be able to tell if we have a pen or a paper clip. So I don't think these 2 events are going to depend on each other. So these are independent events. So we're looking for favorable outcomes. So we have 6 blue pens, which would be our favorable outcome. 6 blue pens. And if we look, we're going to have 16 black paper clips. So these 2 events are independent of each other, so we're just multiplying across. So we get 12 out of 55, for approximately 22%. Some of the slides from today's video are not in your note packet, so take notes in the margins if you need. Here's an example of that. In some of the questions we get today, we're going to be dealing with decks of cards. And not everybody has the same experience with cards, so I thought I'd go over them. In a deck of cards, we have 52 cards. Half of them are red and the other half are black. So that gives us 26 and 26. With a deck of cards, there are different suits. We have 13 clubs, 13 diamonds, 13 hearts, and 13 spades. In the deck there are 4 aces, 4 twos, and so on. So each one of the cards is shown in the diagram. Let's do an example. What is the probability of drawing a heart or a club from the standard deck of cards? Well, let's first decide if this is independent or dependent. If we draw a heart from the deck and we put it back in, and then we draw a club from the deck and we put it back in, do these two events depend on each other? And the key here is replacement. So if I replace that card, these two events would be independent of each other because the draw on my first card won't matter. My sample space will be 52 on the first draw, and my sample space will be 52 on the second draw because of the replacement. So I have 13 out of 52 and 13 out of 52. Those fractions reduced, remember, are a fourth and a fourth. So we're looking at 1 out of 16 ways for that to happen. So let's get focused on independent or dependent. Number 1, picking a card from a deck of cards, then choosing another one without replacing it. Are these independent or dependent? They're dependent. On the first draw, my sample space would be 52. On the second draw, I have a card in my hand, so now my sample space is 51. Question 2, picking a card from a deck of cards, sample space would be 52. Second event, choosing another one once the first card is put back in. Sample space, still 52. Because there is no change, these two events are independent. Example 3, picking a card from a deck of cards and then tossing a coin. Well, cards and coins will not affect each other, so these are dependent events. Example 4, flipping a tail and choosing a day of the week that starts with a T. Again, I don't think these events will have anything that will affect the other, so these two would also be independent events, excuse me. They're independent of each other. Also, this one would have been independent, sorry. Pause the video while you try this question. When you're ready to see the answer, press play. You roll a standard number cube and spin the spinner at the left. What's the probability you get a number less than 3 and the spinner lands on a vowel? So getting a number that's less than 3, your favorable outcomes would be 1 and 2. On the spinner, a vowel would be U. So and means we're going to multiply. So a number less than 3, we have 2 out of 6. A vowel, we have 1 out of 4. We can cross cancel, and we get 112. Mutually exclusive events are events that cannot happen at the same time. Here are some examples of mutually exclusive events. Tossing a coin and landing on both heads and tails at the same time. That cannot happen. Turning left and right at a street corner. Drawing a king and an ace from a deck of cards on the same draw. Those events are all mutually exclusive, so the probability of them happening at the same time is 0. It cannot happen. So if events are mutually exclusive, then the probability of A and B occurring is 0. And the probability of A or B occurring is the sum of the probabilities separately, and then you would just add those. So here's an explanation. Mutually exclusive. Remember, they can't happen at the same time. So if we look at some Venn diagrams, a card cannot be an ace and a king at the same time. But a card could be a heart and a king at the same time. So notice the king of hearts would be in the purple circle and in the green circle. So this example is not mutually exclusive, and the first example is mutually exclusive. I have 8 number tiles, listed 3 through 10 in a bag. What is the probability of randomly choosing a tile that is both even and a prime number? So even and prime. The number I think of that is even and prime is 2, but 2 is not in our bag. So can this be even and prime at the same time? Or in other words, is this a mutually exclusive event? Yes, it is. So our probability for this and would be 0. The second example now is doing that same thing with an or. So looking at our even numbers, 4, 6, 8, and 10. And now let's look through our list and find our prime numbers. 3, 5, 7, and there's our list. So notice none of these are overlapping. So we want the probability of it being even. So I see 4 yellows out of 8. The prime numbers, there are 3 out of 8. And then we should double check to see if there's any overlapping numbers so that I don't count anything twice, and there aren't. So I get 7 out of 8. So going back to our definition of mutually exclusive, the and probability is 0, and then with an or we just add those together. And that's what we found with our number tiles. So a quick summary. Mutually exclusive events, to find the probability of A and B together, their probability is 0. To find A or B, we add them. If events are not mutually exclusive, then we have to worry about this overlap, the overlap. Let's try some practice. A tank at the aquarium holds a variety of fish, 24% catfish, 13% tetras, 8% angelfish. What is the probability of drawing a black tetra or an angelfish? First, let's decide if this is mutually exclusive. Can you be a tetra and an angelfish at the same time? No, you can't. So these two events are mutually exclusive. So to do the or, we don't have any overlapping events, so we're just adding them together. So we get 21%. A teacher surveyed students to determine where to go on a field trip. 43 wanted the water park, 33 wanted the beach, 24 preferred the zoo. What is the probability of a student preferring the beach or the zoo? So because this is an or, we're going to add those two numbers together, and we get 57%. Read through this question, pause the video while you try it, turn it back on when you're ready to see the answer. These are mutually exclusive events. According to the directions, an athlete can only be in one sport. So we just simply add the two probabilities together to get 38%. The last vocab word today is overlapping events, and these are events with outcomes in common. For a standard number cube, the event of rolling an even number and the event of getting a multiple of 3 overlap because 6 would be in both events. It's even and it's a multiple of 3. Our formula now has to change. We would still add for an or, but we have to remember to subtract out the overlap because we wouldn't want to count 6 in both events. So here's an example. Again, I have the 8 number tiles 3 through 10 in a bag. What is the probability of choosing a tile that is both an odd number and a prime number? So let's do our odds first. Odd, 3, 5, 7, and 9. And then we'll pick our prime numbers, 3, 5, 7. So if we use our formula, and let's change this to an or. If we do our formula, our probability is to find the probability A plus B and subtract out the overlap. So we want to do what we were just looking at. So this is an or question. So odd, we have 1, 2, 3, 4. And then prime are the yellows, which we have 3. And then the overlapping numbers, 3, 5, and 7 are both colors, so I'd have to subtract those out. And again, we still have the 8 numbers. So using our formula, subtracting out the overlap is going to leave us with a half. Pause the video and wait for the answers on these two questions. In the top example, we have one item that is overlapping. 6 is even and it's a multiple of 3, so we have to subtract that out. and 3 does the same thing on the bottom.